All right, now we're going to start talking about solutions, and we're going to look at how we measure the concentration in solution. So there's two parts to a solution. There's what's called the solute, which is the minor component. That's the thing being dissolved. And then there's the solvent, which is the major component, and that's the thing into which the solute is being dissolved. And the solution is the sum of the solute plus the solvent. So the concentration unit we typically use for solutions is what's called molarity, and that's moles of solute per volume of solution in liters. So it gives us a measure of how many moles of that solute we have dissolved into the total volume of the solution. So let's look at a typical molarity type problem here. If we have 1 mole of sugar and water is added to a final volume of 125 milliliters, what is the molarity? So remember, the moles equal moles of solute per volume of solution. So our moles are given to us as 1.00, but our volume is given to us as 125.0 milliliters, and we need the volume in liters. So the first thing we would do is convert that volume to liters. So the volume is 125.0 milliliters, and we know that 1 liter is the same as 1,000 milliliters, so milliliters are going to cancel, and that would give us 0.1250 liters. So now all we have to do is take our molarity, which is our moles, which are 1.00 moles, and now our liters on the bottom, 1250 liters, and to divide that through, and we would end up with a solution that is 8 molar in sugar concentration. All right, continuing with our look at molarity, if we have a problem like this, calculate the molarity of a solution made by dissolving 11.5 grams of sodium hydroxide into enough water to make 1.5 liters of solution. So we have the volume of solution, but we have grams of solute, not moles of solute. So the first thing we have to do is find moles of sodium hydroxide. And so we're going to go from grams of NaOH to moles of NaOH. Right, and we need this conversion factor, which is the molar mass. So sodium is 22.99. We have 1 oxygen, which is going to weigh 16.00, and we have 1 hydrogen, 0.1. So the molar mass of sodium hydroxide is going to be 40 grams per mole, right? So 1 mole of sodium hydroxide weighs 40 grams. So we have 11.5 grams of sodium hydroxide. And we know that 1 mole of sodium hydroxide weighs 40.00 grams. So our grams of sodium hydroxide cancel, and it will leave us with moles of sodium hydroxide. Moles of sodium hydroxide. So now we have moles of solute and we have liters of solution. So now our molarity just equals our moles per liter, and we have 1.5 liters. And we divide our 0.2875 by 1.5, and we get 0.19 molar. So we have a solution that is 0.19 molar sodium hydroxide. So we have a slightly different problem here. You have a 10 molar sugar solution. What volume is needed to have 2 moles of sugar? So how much of that solution do we need to take just to have 2 moles of sugar? And to solve this problem, we need to look at molarity a little bit different. We need to look at it as a conversion factor. So if it's 10 molar, that means we have 10.0 moles of sugar in every 1 liter of solution. Right, and that is a conversion factor. Or else we could say that for every 1 liter of solution, there are 10.0 moles of sugar. All right, so those are typical conversion factors that we've seen before. And the way we would solve a problem like this is we would go from our moles of sugar we want to go from moles, and then we want to go over here to a volume, right? So we're starting out with moles of sugar and we want to end up in volume, right? So we're starting with 2.00 moles of sugar, and where we want to end up with is a volume of solution. Right, so we need this conversion factor where we have 1 liter is the same as 10.0 moles of sugar. Kind of sideways with my pen there. Right, and so moles of sugar are going to cancel and it's going to leave us with liters. So we're going to take our 2, divide it by 10, and say this becomes 0.200 liters. So you can use that molarity as a conversion factor, and that's how you would use it to solve a problem. All right, let's look at one last molarity type problem for our solution. So it asks how many moles of hydroxide are in 1.5 liters of 0.25 molar sodium hydroxide. So what we want to do is go from liters to moles of sodium hydroxide, and then to moles of OH minus. So that's kind of the roadmap we're going to follow, right? And so we're going to start with liters. We're given that we have 1.5 liters. The next place we want to go is to moles of sodium hydroxide, so we need to know how many moles of NaOH there are per every liter. And right, our molarity is 0.25, so we have 0.25 moles per liter, so 0.25. Our liter is going to cancel, and that's going to leave us with moles of sodium hydroxide. And for every NaOH, we get 1 sodium and 1 hydroxide, so it's a 1-to-1 relationship. So there's 1 mole of OH minus per every 1 mole of NaOH. So we're just going to go on and calculate through, and we would get 0.38 moles of OH minus if we had 1.5 liters of 0.25. And if we do a little logic check, if we had 1 liter, we'd have 0.25, so we have 1.5 liters, so we should have more moles than we'd have in 1 liter, so everything looks good.